Akash and Akshita were chatting with their dad when their dad told them about a space auditorium which had recently been constructed. Akash and Akshita then pleaded with their dad to take them to the auditorium, and their dad obliged. The auditorium was splendid. When they asked their dad whether the new auditorium was bigger than the old one, he asked them to find it out. Akash and Akshita tried but could not find a way to decide which one was bigger. Hence, they sought out Chitti's help.
Chitti, we need to find which of the auditoriums is bigger, but we are unable to do so. Can you help us out?
Sure, but for this you need to learn the concept of measuring volumes of solids. Do you want me to teach you this concept? In this module, you will learn about volume of solids, measuring volume of solids using cubes, calculating the volume of solids using formula, application of volume of solids. Volume of a solid can be defined as the amount of substance or space that it occupies. For example, we say that the tank holds 450 liters of water. Here we denote the volume of water present in the tank and thus indicating its capacity. Similarly, we say that the cube occupies 2 cubic meters of space and so on. In this lesson, we will be learning how to measure the volume of a solid. Consider 2 tanks. These 2 tanks are used for storing water. We need to find out which of the tanks is bigger. We filled these tanks with water and found that tank 1 can store a maximum of 200 liters of water, whereas tank 2 can store a maximum of 240 liters of water. Among the two, tank 2 stores more amount of water. Hence, we can say that tank 2 is bigger than tank 1 since it holds a larger volume of water and hence has a larger volume itself. In the previous example, we found out the bigger of the tanks by finding out the maximum capacity of water each can hold. But this is not possible for every case. So, here we fill up the solids with cubes of sides of either 1 millimeter, 1 centimeter or 1 meter. This method is similar to the method of finding area using graph sheet. A cube of side 1 millimeter is said to occupy a volume of 1 cubic millimeter. A cube of side 1 centimeter is said to occupy a volume of 1 cubic centimeter, and a cube of side 1 meter is said to occupy a volume of 1 cubic meter. After filling up the solid with cubes, we count the number of cubes which the solid can hold to find out the volume. Let us consider the solid shown in the figure. Now, to find out the volume of the solid, we will fill it up with cubes as shown in the figure. The number of cubes which the solid can hold gives the volume of the solid. In this figure, we can see that each layer consists of 25 cubes and there are 5 such layers. Hence, the number of cubes which the solid can hold is 125 cubes. Also, the cubes are of side 1 centimeter. Hence, the volume of each cube is equal to 1 cubic centimeter. Therefore, the volume that the solid occupies is 125 multiplied with 1 cubic centimeter, which is equal to 125 cubic centimeters. Let us consider the solid shown in the figure. We are required to find the volume of this solid. We know that the volume of the solid is equal to the number of cubes of side 1 centimeter which the solid can hold. In the figure, we see that each layer consists of 24 cubes and the number of such layers is 5. Hence, the number of cubes in the solid is equal to 24 multiplied with 5 cubes, which is equal to 120 cubes. Since each cube occupies a volume of 1 cubic centimeter, the volume of the solid is 120 multiplied with 1 cubic centimeter, which is equal to 120 cubic centimeters. Akash, can you find out the volume of the solid shown in the figure?
From the figure, we can see that this solid consists of some square layers and some incomplete square layers. Now, each square layer, as we can see, consists of 16 cubes. The solid consists of 4 layers, of which 2 are square shaped and the other 2 are incomplete square shaped. Now the number of cubes in the two square-shaped layers is equal to 2 multiplied by 16 cubes is equal to 32 cubes. Now let us calculate the number of cubes in the other two layers. The number of cubes in the other two layers is equal to 15 plus 12 cubes is equal to 27 cubes. Hence the solid in total can hold 32 plus 27 cubes is equal to 59 cubes. Each of these cube is of side 1 centimeter. Hence volume of each cube is 1 cubic centimeter. Therefore, volume of the figure is 59 multiplied by 1 cubic centimeter is equal to 59 cubic centimeters.
In each of these solids which involve a cube or a cuboid, we first find out the number of cubes per layer and then multiply it with the number of layers in the solid. The number of cubes in the layer is equal to the product of the length and breadth. Similarly, the number of layers in the solid is equal to height or depth of the solid. Hence, now the volume of the solid, which is a cube or cuboid, is equal to length into breadth into height of the cuboid. Let us now consider the solid shown in figure. We found that this solid can hold 120 cubes of side 1 centimeter, and hence the volume of this solid is 120 cubic centimeters. Let us now use the formula to find the volume of rectangle. We see that the length of the cuboid is 6 centimeters, breadth of the cuboid is 5 centimeters, and the height of the cuboid is 4 centimeters. Hence the volume of the solid is equal to 6 centimeters into 5 centimeters into 4 centimeters is equal to 120 cubic centimeters. Hence, we get the same answer as volume by using the formula. Akshita, why don't you try solving a problem? The cuboid as shown in figure has a length equal to 8 centimeters, breadth equal to 4 centimeters, and a height equal to 3 centimeters. Find the volume of the cuboid.
The formula for finding out the volume of the cuboid is equal to the product of the length, breadth, and height of the cuboid. Hence, the volume of the cuboid in this case is equal to product of 8 centimeter, 4 centimeter, and 3 centimeter, which is equal to 96 cubic centimeters.
Akash, find out the volume of the cube whose length is given as 6 centimeters.
In a cube, length is equal to breadth is equal to height. Hence, breadth and height of the cube is also equal to 6 centimeter. The formula for finding out the volume of the cube is equal to the product of the length, breadth, and the height. Hence, volume of the cube in this case is equal to product of 6 centimeter, 6 centimeter, and 6 centimeter, which is equal to 216 cubic centimeters.
Akshita, why don't you try solving this problem? A shoebox which occupies a volume of 15,000 cubic centimeters is to be made. If the length of the shoebox is required to be 30 centimeters and the height of the shoebox is required to be 20 centimeters, find out the measurement of the breadth of the shoebox.
A shoebox is in the shape of a cuboid. Volume of a cuboid is equal to the product of the length, breadth, and height of the cuboid. Now, volume of the shoebox required is 15,000 cubic centimeters. Length of the shoebox required is 30 centimeters and the height of the shoebox required is 20 centimeters. Volume which shoebox occupies is equal to the product of length, breadth, and height of the shoebox. Therefore, breadth of the shoebox is equal to volume of the shoebox divided by the product of length and height of shoebox. Hence, breadth of the shoebox is equal to 15,000 cubic centimeters divided by product of 30 centimeter and 20 centimeter, which is equal to 25 centimeters.
Now, why don't you try solving the problem?
Auditorium 1 is cuboidal in shape. The length, breadth, and height of the first auditorium is 40 meters, 30 meters, and 25 meters respectively. Hence, volume of first auditorium is equal to product of length, breadth and height, which is equal to 40 meters multiplied with 30 meters multiplied with 25 meters, which is equal to 30,000 cubic meters.
Auditorium 2 is cubical in shape. The length, breadth and the height of the second auditorium is each 30 meters. Hence, volume of second auditorium is equal to product of length, breadth and height, which is equal to 30 meters multiplied with 30 meters multiplied with 30 meters, which is equal to 27,000 cubic meters.
We observe that volume of auditorium 1 is greater than that of auditorium 2. Hence, auditorium 1 is bigger than auditorium 2.
In this lesson, we learned volume of solids, measuring volume of solids using cubes, calculating the volume of solids using formula, and application of volume of solids. Hope you understood the difference between area of plane figures and volume of solid objects.
Yes, Chitti. Area is the place occupied by plane figures and volume is the space occupied by solid objects.
Very good. See you in the next class then.